Mr. Calix here from Math Magicians, and we will continue with our physics course. Today's topic would be Introduction to Vectors, Graphical Method, or Graphical Techniques. We will start with the first exercise. It says, a roller coaster moves 85 meters horizontally, then travels 45 meters at an angle of 30.0 degrees above the horizontal. What is the displacement from its starting point? It says to use graphical techniques. Okay, so for graphical techniques, since we cannot graph 85 meters or 45 meters on a sheet of paper, we're going to use something for our scale. So we're going to make or invent a conversion that is up to us to make our graph. If we are going to use a ruler, I suggest use centimeters. We're going to make a conversion from centimeters to meters. The conversion, I repeat, is up to scale. So I can say that 1 centimeter is equal to 5 meters just to reduce the line. So if we make these conversions, 85, for example, meters, and we use this conversion, we know that 1 centimeter is equal to 5 meters. And we make our division, for example, 85 divided by 5 is actually 17. This will be 17 centimeters. This would be our scale once we make the conversion. If we do the same thing, but with the other number, the one that says 45 meters, we are going to make the same conversion. We divide 45 divided by 5. Our answer has to be 9 centimeters. Once we have this, we're going to use our scale. So we're going to use our ruler. Okay, you're supposed to have a ruler for this class and a protractor. He says that the 85 meters is horizontally. Horizontally means that it's from side to side. So we have our horizontal line, and we're going to name 17 centimeters. Let's use the line here. Remember that vectors are represented with a line. Let's change at the end. Okay, so we start in 0 until we get to 17 in a horizontal movement. Then it says that it moves at an angle of 30 degrees above the horizontal. So we have to find an angle of 30 degrees above this horizontal. We are going to use our protractor. From the tip of your vector, you're going to find 30 degrees. Okay, make an axis, an imaginary axis here. And you find 30 degrees. As you can see, your 30 degrees are here. Let's mark them so that we can make our line in that direction. 30 degrees are here. Let's move the protractor away, and let's use our ruler for those 30 degrees. And how long is my line? Well, it has to be exactly 9 centimeters, our conversion of 9 centimeters. Let's go back to the lines, and we're going to move our line in that direction for 9 centimeters. Okay, what am I looking for? I'm looking for my resultant. My resultant is, it says to find above the horizontal, what is the displacement? The displacement is your resultant. Is from where you started to where you finished. And this is what you're going to measure. You're going to measure it with your ruler in centimeters. So let's measure that resultant. Let's try to make it straight. There we go. Okay, so as you can see, this resultant in my ruler has to be, we have 19 until here. I'll mark this. I have a 19 until here. And to that 19, I have to add the rest, right? And I have to add what, 26? Let's call it 26.2. Okay, so we know that the measure of this, well, sorry, 19 plus 6.2. 19 plus 6.2 is actually 25.2. Okay, if you make your addition of your ruler. If your ruler is long enough where you don't have to do this, you just press your ruler and your ruler has to say that it's 25.2. Okay, once you have this is in centimeters. We have to go back and find our answer. Okay, so we will continue here. We know that the total measure from this vector here is 25.2 centimeters. We have to convert it back to meters. So what we're going to do is that we're going to switch our conversion. 5 meters over 1 centimeter. Okay, we cancel this and we multiply these two numbers, 25.2 times 5. I have an exact answer as 126 meters. That is your displacement. Then the angle. Okay, we're still missing the angle. As you can see, the angle now, if you make an axis here, your angle now is not moving to the south or it's just moving above the horizontal, as you can see. Okay, so we're just going to find the measure of the angle by putting the tip of our protractor there, and as you can see, it's 10 degrees. Okay, so the angle would be 10 degrees above the horizontal. And that would be your answer, 126 meters, 10 degrees above the horizontal. Okay, let's continue. A pilot sets up plane's controls thinking the plane will fly at 2.50 times 10 to the 2 kilometers per hour north. If the wind blows at 75 kilometers per hour toward the southeast, what is the plane's resultant velocity? Okay, so for this, we have 2.50 times 10 to the 2. And as you know, kilometers per hour would be very hard to draw in a sheet of paper, so we're going to make our conversion. I'm going to say here, since it's a high number of 250, if you see it, and 75, we're going to use a higher number than the last exercise. I'm going to name that 1 centimeter, in this case, is equal to 15 kilometers per hour. Once I have this, I'm going to start my conversions. I have 2.50 times 10 to the second power, and this is kilometers per hour. If I want to make that conversion using this scale, I have to divide it by 15. Okay, so if we make this conversion, we will have 2.50 exponent to the second power divided by 15. I have as an answer 16.6 with a quotation bar. That means that it will just be 16.7. Okay, once we round it, centimeters. Then we have 75 also. 75 kilometers per hour. We are going to do the same operation, 15 kilometers per hour. We simplify this and we make this division of 75 divided by 15 is 5 centimeters. Once we have that, this one says that it's moving directly north. That means that we're going to use vertically our ruler for 17. Okay, so we're going to have to surpass our answer there for 16.7. Okay, we make our line, our vector. From 16.7 is around here until you get to the 0. And there you have your first vector. Then it says that if the wind blows at 75 kilometers per hour toward the southeast. Now, toward the southeast, we have to find a conversion. But before we do that, we're going to check something. Remember that in your axis, you have this information. You have that this is north, this is south, this is east, and this is west. Southeast is here. And since they don't give us an angle, we're just going to use the half of 90. That would be 45. So I'm going to use an angle of 45 degrees. I'm going to turn my protractor, locate it in the tip of the first line that I made, and then I'm going to measure 45 degrees. Okay, 45 degrees is here. I'm going to move or draw my line actually 45 to 45 degrees, but the line has to be only 5 centimeters long. So we make our line. I'm going to make the line and then I'm going to accommodate it. Let's make our vector. Okay, our vector is from here for 5 until there. But we have to fix it for 5 centimeters. And the angle of 45. There you go. That's your vector. Next thing is find the resultant. The resultant, remember, that is from where you started to where you finished. And you just measure a line with your ruler. Let's measure it. And then we make our own conversion. Okay, if we measure this line, we have approximately 13.7. Okay, so I'm going to move my ruler and it would be 13.7. I'm going to add space here. So we have that the resultant is actually 13.7. Okay, 13.7 centimeters. Remember that what we do is that we turn back to, in this case, kilometers per hour. So I have that 15 kilometers per hour over 1 centimeter. We make our multiplication of 13.7 times 15. 13.7 times 15 is actually 205.5. So we're going to round it to 205 because of significant figures, kilometers per hour. Okay, so that would be my answer of the resultant. I still need to find the direction. For the direction, I'm going to turn my protractor back to normal. There we go. And then we're going to measure our angle. But how are we going to measure our angle here? We're going to try to imagine an axis that belongs here. And our angle is actually this one here. And as you can see, your angle is approximately 75 degrees. And it's moving to the north, right? So it would be north of east. So the angle would be 75 degrees north of east. Thank you for watching. Don't forget, physics is life.